All right, I've cobbled this little scene together here, just as a little homage to Illusion of Gaia, and we're going to chat with Gaia, except he's going to be an AI bot that's running locally for free on your machine. We're going to use Oobabooga for that. If you're not familiar with that, that would be surprising, but it's a web front end for talking to a language model. You can download lots of these language models for free off of Hugging Face, and Oobabooga will allow you to chat with those models to whatever extent your graphics card is capable of. That is a stipulation, obviously. So there is a one-click installer here. What you need first is Python. So one thing to keep in mind is I believe Torch, which is a Python module, is still dependent on Python 3.10, not this latest 3.11. So if you go to the full list of downloads, you go right here to 3.10. There's the latest 3.10. That's the one I would recommend getting before you go to Oobabooga. So once you've got Python installed and added to the path, you can run this one-click installer, and then you'll get a directory structure like this. This start windows will install if you haven't already, but that will start your little web server up. And what it'll look like if you double click that, it's going to open this prompt right like so. And then what you're looking for is here running on local URL, and that's 0000 is just localhost, but 7860 is the port it's running on, and that's how you get there. Once that's running, you go to, like you see here, localhost :7860 if you're on your own machine like that, and this is what you're greeted with. The main steps you need to follow here are first load the model. Now, if you don't already have a model, you can go to Hugging Face. This user of the bloke has pretty much everything. You can download any of the models here for free. So let's just take a random one. If you go into it and you go up here to copy, that copies what essentially is this path here. And then you go here to paste that in here and then click download. It'll do the rest for you. And then you can pick it here and then load the model. Then it's ready to be chatted with. More recently, there are these Llama 2 models, which have a longer context length. So you see 4096 here. Most of the other models that are not Llama 2 are limited to 2048, and that will be the default, but that's the only reason I have that going to 4096. Now, to actually connect to it from something else, like not this web UI, you need this API flag checked. You can check it here and then toggle, and I believe that will do the trick. But an easier way is to have it do that every time. So in this web UI py file that you'll see, that has these command flags right at the beginning of it here, this --API, that'll make it load with that set. Listen is not required if you're doing everything on one local machine, but if you're running Oobabooga on a server machine or your desktop PC, for example, and you're connecting to it from a laptop or some other machine, then you need listen so that it can connect to another machine on the network. So now we need to look at the scene setup. So we get those from the Oobabooga examples. We've got API examples right here and this example chat stream. So here are all those parameters, and that's what I use as a model. And down here, this is the Python way to connect. So we need to duplicate that in C#. It is possible to run a Python script from Godot, but it's kind of a cobbled together process. So if we can do it from C#, so much the better. So right here, we've got the just root of the scene. I have this Oobabooga test on here. That's the script. So we have that, and then there's going to be the talker script, which is basically going to act as an intermediary. So here's the script that has the parameters. This is going to be a class, so we're going to have an instance of this, and that's going to be what we pass to Oobabooga. And these are all those same parameters. So I have the equals after it to default to what I saw there. So if we go through these, you'll see some of these in here don't have one. Those are going to be null by default, and that's fine. Those are optional ones. So going through this, that way you can see everything as necessary. This is the same as in the Python script. All these parameters, by the way, are ones you're going to see on the UI, or most of them anyway. So I'm just going to go through these, obviously pause it if need be. I'm defaulting this truncation length to 2048 because that's what most of the language models have as a maximum, except for Llama 2, which is recent, and I will set that manually if that's the case. So if we go back to the generation web UI, if we go over to parameters, you'll see a lot of those that are in the JSON are parameters that you would set here. So here's kind of a visual representation. And similarly, because I'm using a Llama 2 model, I switched it to 4096, but you can just leave it at 2048 for these purposes just to get things working. It's not going to approach that. So here we're going to go to this test script. Again, some of this stuff is just the objects that are in the scene, like the dialog text, the input text box, a text sound, which is optional entirely. So an important one here is the prompt. We're going to store what we're sending as a prompt here. And the animation player, again, I just added frills there so it looks like he blinks and talks So here in the ready part, we're going to get the animation player node. I'm going to store these. Actually, just to make a little more sense, put that like so. So here we're going to subscribe to the events that are going to get sent over. So as Oobabooga is returning text, each time it returns a little more text, I'm going to shoot an event off, which will be picked up here and then trigger those methods. So when the text update event gets fired off, it's going to run the display text method. So I'll show that when we get there. So the prompt, I just put a bunch of quotes from Gaia in there just so it has some amusing resemblance to him. So here we're basically polling for input. The text box object is going to accept text as long as it has the focus, and we don't really have to do much with that. The one exception being enter is going to be what I trigger sending the information to Oobabooga and getting the response back. So this is just if any key event, like any keyboard event, is pressed, I just have the input text grab the focus just to make sure it has it. Basically, I'm going to disable the ability to edit that text box if we're still receiving text back from Oobabooga, because that could get messy. That is, by the way, just a field that we have on text input. See, we have editable right here, so that's going to be triggered as we need it to be. So here we're going to do plus equals. We're going to add to this prompt. We're not going to replace it, because the way those language models work is it's all based on the history, and it can kind of derive some context that way. So we're going to add whatever is in that input text box that the user just typed in. This is just logging. And this Oobatalker prompt AI, we're going to send that the prompt, and then we're going to clear the text box. So where that's going is over to this Oobatalker. We're going to call this method, and it's going to feed in the prompt. So before we go into that, here are those events I was talking about. I'm defining the text update and the text finished events. The reason I'm defining this history here is because that was one of the JSON fields. Because it's nested, I was having issues getting that sent to Oobabooga correctly, because I believe because of the quotes, and I use Newtonsoft JSON to serialize that object, and when it got to this nested one with the quotes and everything, it just didn't work out. So I'm manually setting this one also because it doesn't really need a change. This is kind of what it looks like. So when I looked at the Python script, this is exactly what would get passed in, and if I tried to deserialize that from C#, I would get something different regarding the quotes, or no matter what I did, it just didn't come out to this, and this is what I needed. And just to give an idea what's actually going on, when you send something to Oobabooga and it sends data back, it has what you sent it and then its response. So basically, this is an array, obviously, and the last thing in this property is going to be what we're going to grab later. So this is a good way to visualize that. I believe the difference here is it's the same thing in Visible, but we can see here it used the HTML coding. So I think they're identical, except the Visible one is really for what should be put on a web page in HTML code, so that way it formats the text. So in our case, we don't need to display it on a web page, so we're just going to use that internal variable that comes back and get the last item. So these are just variables to store when we get the response. This is also from the Python script originally. This is, as you can see from here, this is what it defaults the API to, the port 5000 or 5005 for the stream. And that's what we have there, 5005. And we're using streaming because that way it's not just all at once. It comes back little by little. Message finished. Obviously, that's just going to be a flag, which we'll see where we use that. I don't think I ended up using this. Ignore that. So again, prompt AI. So this is where we were in the test script. So they've pressed enter. They're going to call this method, and they're going to send in the prompt. So the user input is going to be the prompt right here, and that's the name of that JSON field, this user underscore input. I would make sure and keep those names exactly the same, by the way, because it's going in as JSON. So if we change the naming in any way, it's very likely not going to work. And this is where I'm just creating an instance of this object. So I'm creating a new one of these, and it's going to have all the values I put in here as defaults. So that's what this line does. And then here, these next two lines, I'm manually setting a couple of those fields. The user input's just the prompt, of course. And like I said, I'm using a Llama 2 model, so I set the truncation length to 4096. Again, that's not terribly important. So here, every time we're setting it to the history, which is up here. And this is what screws up the formatting with the nesting. So here, we're setting the request, which we're actually going to send. These are methods from Newtonsoft, which is, again, this library that we imported. I installed that through NuGet. I have a tutorial on that, but just in brief, the package manager, you can just go to install new package and get it from there. We just sent a new prompt, so obviously message finished is going to be false. So right here, we send in this Ooba object here, And formatting indented does kind of matter here. It's basically, that's going to, instead of stringing it out all unwrapped text, it's going to put each property on its own line and make it look nice. But more than look nice, as I'm going to iterate over those line by line to fix that history issue I was talking about. This is also important. So these are settings for the JSON serializer, obviously. This null value handling just ignores those fields. So what that means is these fields are not going to be included in the JSON that actually gets sent after that serializing is done. That does matter because I tried that. Having them specified but having a null does mess up the Oobabooga backend. And yeah, here, just like I described, is a terrible hack in order to get that JSON format the way I need it to. Again, I need it to look like this, but the serializer doesn't give me that. So this manually does that. It just iterates through every line of the JSON that we just got back from this serialization process. You're literally splitting the string by every new line character. And if it contains the history with the quotes, then we're going to set that line to the history which I defined above, which is the way I need it to be right here. And if it's not that line, it's just going to add that line. So that way we just rebuild the string, but we specify the history property. So this is the part where we're actually going to connect to Oobabooga, and this is not fun stuff. So what it does is it opens a WebSocket, and my understanding is that is just a connection that's bidirectional and it stays open while we're getting this text back. So there's a protocol for this, and I'd follow this code carefully because C#'s implementation of this is a little...
Problem of type 2094 has occurred. What are the 2093 other problems I've just missed to get to that one?
Is not the most intuitive, and there's a piece of it that does not play great with the Python, which I will show, but I don't think it actually matters. So cancellation token, I believe if there's going to be a cancellation, it just propagates that to anything you pass that token to. So if you had, like, for example, we've got a send method and then we've got a receive method. Both of them take that token. So if the process gets canceled, I think that token then kind of notifies all of those processes. So this is asynchronous, and that's important because otherwise it would lock our UI up. So we're doing await connection, essentially. And this is the, what was specified from the Python script. Again, right up here, this is that URI. A byte array is just going to be a buffer. Now, I'm not exactly sure what counts as a byte. I don't think it's just a character, because I had this at 8192 and I kept going back and forth with the chatbot for a little bit, and then it actually broke at that position. So we do need storage space for the large context of stuff that's going to be in there. And here the response variable, again, that's right here. So if we had already done this, this would have been populated with whatever was returned. So it's just resetting it. So while the WebSocket is open, basically, and that message finished flag is false that I set up there, we're going to do this send string. Basically, you pass in the WebSocket object along with the string that you want, and this is going to return the task that gets returned from this send async process. This is really the C# process that's going on here. But I think basically what's happening here is it's got to be sent as bytes, and then you get your text ends up going in here. But anyway, don't need to beat that to death. So anyway, we've sent the JSON to Oobabooga, and this waits for it to come back. And again, this is all going on while the socket is open, because this is a continuous process while it's sending back additional chunks of text. This is just, again, from a code block. I don't think I've ever tripped this in this program, but I believe this is like if the server closes the connection, then we do the same. So again, here we're kind of undoing what we did in that send string down here, where we're encoding it into bytes. And now we need to get back the letters. So this is going to get it as a JSON object. We're going to parse that string, basically. And this return JSON object select token, that lets you get an element in the JSON. And what we're after is this again here. So to visualize, out of all these elements, that select token just says, give me the one that you specify there. It makes it a little easier. So we're saying if the history is there, do the following. So this is that history.internal. So internal is really... So again, we're going to get the internal because that's the text without the HTML formatting. And fortunately, Newtonsoft has a nice method that will get us the last element of that. So this right here is going to have the text that we would normally see as a response from the chatbot. So here's where we're going to fire that event off. And then we're going to send that response over so that way we can have it displayed in our text box. So the event, that's another property in the JSON, another one of those lines. We're going to get the event. That'll say stream end when it's finished. So we're going to go to finish message in that case, and also if the history is null, we're going to go to finish message. So that's awaitable. It's a task down here as well. And here we're going to pass in the WebSocket, the response, the message. the cancellation token source and token. So here's where we set the message finished flag to true. That's basically an extra check so that it doesn't go through this process if we're finished. This close async we're going to put in what type of closure, which should be normal. This can be anything here. This is just user readable reason that we're closing it. And then the cancellation token is passed in case of a cancellation. So this is where we have a little issue. Like C# does not necessarily play very well with the Python backend. There's basically a handshake that's supposed to go on between the client and the server to properly close the connection. And for the life of me, that doesn't work too well with this backend. What will happen is you'll see an error message pop up in Oobabooga. And depending on what order you do stuff here, I've actually had it say, okay, sent the close signal, but the handshake doesn't complete and it still throws an error. Bottom line is it doesn't really matter. It still seems to work. It's just Oobabooga complains that there's an improper closing of that connection. So I don't know how to fix that right now, but this is what I'm doing just to make sure that we don't leave it open, because that, if you were not connecting to a local machine, that is a security vulnerability. So here I'm trying to close it. What usually is actually happening is it successfully sends the closed signal, but we don't get the closed signal back. So if it's not closed, it'll usually be closed sent. Then this cancels and disposes, make sure we get out of that, and then the WebSocket itself gets disposed of, and I log the state here, and usually this says aborted. So then this is going to fire the event off and send that message over to this script again, and this it's an awaitable task, so it returns the task is completed. So to bring this full circle, again, this is where we subscribe to those events, that text update and that text finish that just got fired off. It's going to do flag finished. So let's back up a little bit. So to review here, this is where every time we get a new piece of text, this event's going to fire off. So text update's going to go to display text here. And this is just animation stuff. So if you don't want to, you don't even have to bother with that. The important thing is right down here. So when you get it back, it will have response colon, and that's how I think the chatbot is separating. You know, you'll start your response with u colon or whatever you put in there, and then when you get back, it has response. So I'm stripping that out of what we actually display in the text box here, and then we set the dialog text to whatever that text is, and it's going to be a little more each time. It returns the whole string each time, which kind of inefficient, but that's how it works. And this is optional too. This is just to play a little sound effect. And then flag finished. So this will fire the event off after it's finished with the message. And now after that happens, the event's been subscribed to. So then this is going to run. So basically he stopped talking. So I had him go back to the blink animation. Again, that's optional. And then the prompt, we're going to add a new line and then put the response colon back in. And I think that helps the AI separate each iteration of dialogue, and then set that flag for input text editable back to true, so they can now type in that text box again. All right, let's give it a try now. And we up and running, cool. Should be an easy one. Okay, it accepted my prompt, but that's not really very convincing, I suppose. Oops. Try that. Alright, not bad. So cool, there we've got some AI chat in Godot. There is another thing I do want to talk about very quickly, which is the speed. So like in a case like that particular example, I've got a big font and it's easy to go off the screen quickly. The Oobabooga settings do have this max tokens per second, and it's currently set at 0. And if I were to change that, let's say to, I don't know, 4, maybe 5, you can limit the speed right from the server side, so to speak. So let's try it again with this in place, and we can see it scroll at a more reasonable rate. Let's try some different stuff here. It's not AI for no reason. That's BS, yeah. Now we can see it's more paced here, and it's trying to justify him holding the button to use a dark fryer, which is just outrageous. I mean, come on. No, I don't think that's true, but not everything AI says is true. We know that. feel bad for the source of all life here. You can see response popped up there, so that's another thing we should just be aware of is the race condition issue. So even though I'm taking response out of this, it looks like in that case the command to display it on the text box happened just before the variable was updated. So that's kind of a bummer. You could probably make that like asynchronous or whatever. See how smart he is. Looking good, looking good. Okay, I think he actually was shot directly by Carl Weiss, who was then killed right after, so this isn't bad. All right, enough of that. So yeah, awesome. So like in this case, I'm just using it in, talking to Gaia here. But obviously what's so cool about that is that theoretically you can hook this up to RPG characters and just tie them all to the AI and have them each have a different context or a different prompt that starts out, because you can do more than I did. I didn't really try hard, but you can set that context up in order to influence the behavior. And it's obviously a little bit too fragile to be practical in a released game right now, but maybe we'll get there in some near future. One last thing is, while I was sending those messages, you can see here's the error I was talking about before, where it says no close frame received or sent, even though I did send it. So that's the handshake problem, where you do send the close request, but it doesn't come back. So both sides think there's a problem. But ultimately, it generates the output, and the WebSocket does get closed, just not so gracefully. So there we go.